more detail on this up on the Medium blog, so medium.com/Corda. The 4.2 release is actually follows our new numbering scheme, so be sure to go ahead and read up on what 4.2 means in terms of our numbering scheme we're using today. 4.2 is actually a fairly significant release in terms of the amount of engineering work delivered, so we'll talk a little bit on the impact of that. But first we wanted to talk about the primary area we delivered in 4.2 is around the hardware security modules and key management. So I'm going to go ahead and start with talking to Valerio about this. And Valerio, I think it would be really helpful if you can help us understand how keys are generated in Corda, how that process works with the doorman, etc., and how those keys are generally managed.
Yeah. So at the moment, Corda nodes act as their own certificate authorities and generate a pair of signing keys after they have been registered as part of the network. And they use those to sign the transactions they are involved in. There's also other types of keys that are generated by the node that we have focused as part of this release on securing inside hardware security modules. These include TLS keys, so used to establish a secure connection between parties on a network. And this includes confidential identity keys, which at the moment are used to exchange information and create transactions between nodes in a, as the name suggests, in a confidential way. So confidential identity keys at the moment are generated on a per transaction basis by the parties that are involved in a transaction. And they're used to make sure that no one else outside of the parties involved in a transaction knows who actually has participated in this.
Fantastic. And there's three key types really in a Corda node then. So the Corda node being certificate authority,
Yep.
That certificate authority generates identities related to TLS, related to the signing keys, and related to confidential identities. And just a reminder for everybody, in Corda 4.0, we initially released hardware security module support for storing the signing identity keys. So the 4.2 release adds that further support for those two other key types, being TLS keys and confidential identity keys. Great, thank you, Valeria. So what was the previous state around this?
So as this slide suggests, the confidential identity keys were stored in plain text in the node's database. There was a dedicated table that held the hash public key, and the private key that were generated as part of the confidential identity key generation process. Of course, this had some security concerns associated with it. So node operators had to enable encryption in their database to prevent basically those keys from being accessed and exposed. And the node itself has access to all this information. So if a node gets hijacked in some way, that information can be exposed. So as we had already started introducing HSMs to work with Corda as part of previous releases, we also thought that confidential identity keys were a good candidate to be added as part of this one.
Fantastic. Okay, so, and I think we talked a bit about the motivations on this around increased security, but I think it's important to understand the implications of confidential identities in terms of scalability, as you note here. And at a high level, I guess, if you're creating a key pair for a transaction that's confidential, you could conceivably create millions of these keys. So Dimos, might actually be a good one to pull you into this, is what are the implications of this in terms of which hardware security module you would select potentially, and how have we engineered against that?
Yes, so the main challenge we had during the design of this feature is that we couldn't just use the existing approach we use for the legal identity keys because hardware security modules have certain limitations in terms of their capacity. So essentially the feature would be subject to any capacity constraints of the HSMs we would need to integrate to. So a secondary requirement, as we mentioned, was that the node would be able to create and use up to hundreds of millions of confidential identity keys without being subject to any capacity constraints of the HSM that is being used.
Okay, fantastic. And does this mean that our customers should choose an HSM based on their use of confidential identities? Are there particular HSMs that potentially would manage it better, or are there cost implications potentially in how they charge?
Yeah, that's true. That could be a factor to take into consideration. What we would like to do is scalability not being a problem on that, so not forcing a decision on which vendor to use because of this limitation, so that they can choose independently of the capacity constraints of HSMs.
Okay, fantastic. The one thing that stuck out to me is we currently have support for Azure for the Azure Key Vault, which is fantastic for cloud deployments. However, they charge per key pair managed on a regular basis, so that feels like it's an example of where you should be conscious of the environment you deploy to and potential costs for that. Fantastic. Okay, so let's talk about the solution overview. And Dimos, this would be a great one if you can help us understand, since you're the engineer who led this work, how we've gone about implementing this.
So we considered several different approaches for that, and we ended up choosing the approach of wrapped keys. The way this approach works is the following. A master symmetric key, an AES key, is created inside the HSM by the node. And then every time a confidential identity key needs to be generated, this is generated, and then the private key of that key pair is encrypted with a symmetric key and exported from the HSM. And then the node can store in its database the public key as before and the encrypted private key material in the database. There is one thing to note here, which is to achieve full security, we would have to make sure that the node never gets access to the private key material, as we mentioned before. And in order for that to be done, the generation of the key pair needs to be done completely in the HSM, as well as the signing of the transaction needs to be done inside the HSM, so that the private key material is only accessible temporarily to the HSM and never to the node. So because of that implication, we will see we have two different modes for that feature later on.
Fantastic. Okay. So let's talk then about the two available modes you just talked about.
Yeah. So there are two modes for this feature, as we mentioned. The first one is what we call wrapped, which is the fully secure option, and the one that we would recommend customers to use. And the second one is the degraded wrapped, which is a bit less secure than the first one, but it might have support for some additional HSMs potentially in the future that do not provide the necessary APIs for the first mode. So in the first mode, as we mentioned, key generation and a signature is done inside the HSM, so the private key material is never exposed to the node at all. And all these operations are delegated to the HSM. In the degraded wrapped mode, key generation is done inside the HSM, and then the node inside the node, and then the key is encrypted by the node and sent to the HSM. And then signature is done in the same way. The private key material is temporarily exposed in the node for the signature while being decrypted and then thrown away eventually. So the current state is we have support for those two modes. We support the Securasys Primus X HSM in the wrapped mode, the fully secure mode, and we also support file-based key store use, which is used in the place of an HSM, but this only supports the degraded wrapped mode.
Okay. So in terms of degraded wrapped mode, I noticed we only have Securasys Primus X at this point for confidential identities. We'll be adding future support, I assume, for the other supported HSMs.
Yes, this is, as described previously, we need the HSM vendor to provide some specific APIs for that. So as long as the vendor can provide these APIs, we will be able to add support for wrapped, or if there is big customer demand, we can temporarily add support for degraded wrapped, which is easier to implement with APIs most of the vendors provide, and then potentially upgrade it to the wrapped mode when the vendor can provide us these APIs.
In degraded wrapped mode, if the node generates the key, does it then pass that key for storage in HSM and discard any evidence of that key at the node level?
Yes.
Okay.
So the key is passed to the HSM so that the HSM encrypts it with a symmetric key that is inside the HSM.
Okay.
And then is returned back to the node, which stores it in an encrypted form in the database itself.
Okay. And then at the time of signing, it request that to be decrypted to
Exactly,
sign.
temporarily to sign.
Okay.
Yeah.
And the node disposes of the
Yeah.
key at that point. So there is a moment in time when there's a risk for
Yes.
exposure to the key.
Yes.
Okay,
Correct.
so that's one of the obvious trade-offs. Fantastic. And then externally visible changes. So how is, for the more technically minded on this, what is the deployment going to look like?
Yes, so the same table is used as the one we saw before, but it now has two additional columns. The one is, as we see in the slide, called private key material wrapped and contains the private key material in the encrypted form. And the next one is called scheme code name, which essentially contains some metadata related to the ciphers that are used and the algorithms that are used for the asymmetric key pair related to the confidential identity. And then one of these columns, either the private key or the combination of private key material wrapped and scheme code name, will be populated in the database. The other one will be null, depending on which, if you have enabled this feature or not. In the key stores folder, which is called certificates, if you're using the degraded wrapped mode with a file-based key store, you will see now an additional key store file with the name wrapping key store .pkcs12, which essentially stores the symmetric AES key, which is normally stored in the HSM and is used for wrapping the confidential identity keys. And with regards to the node operation, the master key is generated during node registration in the same way other keys are generated by the node. And the confidential identity keys are generated, as we mentioned, on demand during runtime. So this helps because operations shouldn't be that different, and any backup processes will be able to cover the keys introduced by this feature.
Okay, fantastic. Just a question for my own understanding, others may have the same question. The key store, the symmetric key that's stored on disk locally, how is that used? And is that a public key or is that...
So the key that is stored in this new key store file is an AES symmetric key, and is the one that is used to wrap, to encrypt the private key of the confidential identity key pair,
Okay.
and also unwrap it before signing.
Okay. And that's for the mode where the signing is done by the node instead
Yes,
of
the degraded wrap mode.
And as a symmetric key, it's not something that needs to be kept secret because it's a public key. It's used to encrypt keys that can then be decrypted only within the HSM. Is that correct?
So if the local key store is used, that should probably be protected with a password.
Okay.
And being backed up as well, the same way we would do with an HSM. So the AES key, which is used as the wrapping key, is highly sensitive because all the private key material for all our confidential identity keys are only secure if this wrapping key is not exposed. As long as this wrapping key is exposed, essentially we can consider all the confidential identity keys exposed because they can be decrypted with this key.
Okay. Okay, that is definitely something to keep in mind.
Yes.
And there's obviously a preferred mode of operation here. Okay, fantastic. And then last part would be just around the specifics of the configuration options you have noted.
Yes, so this link available in this slide contains all of this information, so you should be able to get started just with that. But going briefly over that, there is a new block, a configuration block, which is called Fresh Identities Configuration. If that block is present, it means the node will use this feature, and it contains several metadata inside. One field is called the mode, which defines which mode we need to use. The other one is the master key alias, which defines the alias under which the key will be stored in the HSM or the local key store. And the last one is the crypto service configuration, which is specific to each vendor and determines what kind of HSM we will use and potentially other configuration files that contain credentials and things like that. And this is exactly similar to the entry that we use for the regular HSM setup. And also, from now on, a warning will be shown during startup when you're using Corda Enterprise that warns the operator that there is a more secure option for confidential identities. And this warning can also be disabled just by adding the entry disable fresh identities warning in your node configuration.
Fantastic. In the setup instructions for the specific, so at this point there's one specific brand of HSM that's supported. I assume the specifics of the setup for that HSM are in the instructions, or do you need to
Yes,
rely on
so
something?
if one visits the existing page for legal identity keys, it's exactly the same configuration as shown there.
Okay, fantastic. And then Valerio, what is the impact in terms of backwards compatibility? So customers are running older versions, and then migration path to the current version, and then of course where are we going to take this next?
Yeah, basically there shouldn't be any problem. So customers who currently use confidential identities should be able to transact normally with nodes that have enabled this new feature. What will practically happen is that the old keys will stay in the same format, and all the new keys will be generated by whoever is using this new feature in wrapped form or integrated wrapped form according to what mode they have selected. And yeah, the old keys can still be used to sign transactions, so no major change there. I guess the main note to add is that we expect the master wrapping key to be unique and long-lived. So as Dimos was suggesting before, that's something that needs to be either secured in the HSM and backed up regularly. And yeah, that would be it.
Okay, fantastic. And we'll try and do more communications around what comes next, either via the blog or another video. Fantastic. And I think what we'll do is, I know we have a demo that Dimos is going to do. So, and I think we'll record that separately and post that separately, just so we can actually
we'll
get
try
this
to
live.
demonstrate essentially how you can configure your node and use an HSM to take advantage of this feature using a cloud HSM from Primus X.
Excellent. Okay, great. And we'll put that up as a separate recording. Fantastic. Thanks for your time, everybody. If you have any questions on this, it's probably best to jump up on our public Slack channel or check on Stack Overflow. Those are the best ways to get a good response that others can use. So, and if you had any questions on the future compatibility of HSMs, etc., or if you have specific needs on that, feel free to send an email to product@r3.com. Thanks, everybody.